Hello, this is my assignment 2 submission. In this assignment, I implemented a neural network model using the ARIES dataset. I'll now explain each part of the code and answer the required theoretical question. My name is MD Tausif Siam and my student ID is 1015155575. At first, I have saved a variable called filename for the image.csv file path. Then I loaded the dataset using pandas and stored it in a data frame called arrays. I displayed the first 5 rows to verify that the dataset loaded correctly. After that, I converted the categorical species labels into numerical values because neural networks require numerical input. I verified the species column is now converted into numerical values. And in 3A, I selected the first 4 columns as the input features. Then I selected the last column as the output label. And then for 4A, I split the dataset into 80% training data and 20% testing data using train test split. And I used random state to 1, 2, 3 to ensure reproducibility. In 4B, I verified that 120 samples are used for training and 30 for testing. After that, in 5A, I applied one hot encoding to the labels because this is a multi-class classification problem with 3 output classes. In 6A, I built a neural network with 2 hidden layers of 100 neurons each. Using value activation really helps the model learn non-linear patterns. The output layer has 3 neurons with softmax activation because there are 3 classes. After that, I compiled the model using Einscope optimizer and categorical cross entropy loss, which is suitable for multi-class classification. I trained the model for 20 epochs with a batch size of 10. Epochs represent the number of times the model sees the entire training dataset. After that, I evaluated the model on the test dataset. The model achieved approximately 96% of accuracy, which indicates good generalization performance. In 9A, I created a smaller model with 10 neurons in each hidden layer. The smaller model achieved approximately 96% of accuracy. The larger model performed slightly better due to higher learning capacity. So for this question answers, for 10 AI, more layers and hidden units increase the model's learning capacity, which may improve accuracy but also increase the risk of overfitting. And the next question is, do we always suffer from overfitting? We do not always suffer from overfitting. It depends on model capacity, complexity, dataset size, and training duration. Next, how can we detect overfitting? Overfitting can be detected when training accuracy is high but test accuracy is significantly low, or when validation loss increases while training loss decreases. Next question is, how can we reduce overfitting? So overfitting can be reduced by reducing the number of layers of neurons using dropout layers, applying L1 or L2 regularization, increasing the size of the training dataset, using early stopping, reducing the number of training inputs. This technique helps the model generate better to unseen data. In 10b, I modified hyperparameters such as the optimizer and numbers of epochs to observe changes in performance. The demonstrates how model parameters affect accuracy and generalization. The accuracy is 96%. In conclusion, this assignment demonstrates how neural networks can classify the iris dataset effectively and how model complexity and hyperparameters influence performance and overfitting. Thank you.